Hey everyone, today I'm solving our work, energy and power. This is AS Physics 9702 multiple choice questions. This is paper 1. This is going to be part 1 of these videos. This is part 1 of these videos. So I hope you learned something from these videos. So without wasting time, let's start with the first question. A spring is compressed by a mass as shown. So before compression we can see, and after compression. Which statement describes the changes to the energy of the spring when it is compressed by the mass? Number 1, the spring changes both gravitational potential energy and elastic potential energy. The spring gains, not changes, the spring gains both gravitational potential energy. Actually, it loses gravitational potential energy when it is compressed, so this is wrong. The spring gains gravitational potential energy, it actually loses gravitational potential energy. The spring, because it is compressed, the vertical height decreases, so it loses gravitational potential energy. The spring loses both gravitational potential energy and elastic potential energy. Actually, it gains elastic potential energy because the compression increases. So the answer is most likely going to be D, because the spring loses gravitational potential energy as the vertical height decreases, and it gains elastic potential energy as the compression increases, because the elastic potential energy will be equal to a half k times x squared, where this time x will be the compression. So as the mass compresses the spring, the compression increases. A motor is used to lift a load vertically upwards. The load has weight W. The motor produces useful power output P. The load is lifted at a constant velocity V. Which expression gives the time taken for the motor to lift the load vertically upwards through distance D? Okay, so starting with the power, we know that power is equal to energy over time, the rate of transfer of energy, which implies that time is equal to energy divided by the power. Also remember that energy can be work done, which work done is force times distance. So this will be divided by P, and the force will be the weight, which is W, then times the distance, which is times the distance D, then divide by the power. So our answer is automatically going to be C, the weight times the distance over power. The lamp is switched on for 2 hours. The power input to the lamp is 1 watt. The energy given out by the lamp as light is 7 times 10 power 3 joules. How much energy is converted to other forms by the lamp? So we know that power is equal to energy divided by time. They have given us the power. We want how much energy is converted. So let's find first of all the energy input. I'll quote energy I, that is energy input, is going to be equal to power times time. The energy input will be power times time. So this is going to be the power, which is 1.0 times the time, which is 2 hours, but I will change it to seconds, so it is times 3600. So for my calculator, this is 2 times 3600, which is 7200 joules. That's the energy input. But the energy which is given out by the lamp as light is that. So the energy output, I will call it E naught, or energy output is the energy given out by the lamp as light is that. So the energy output is 7, that is 7000 joules. So how much energy is converted to other forms by the lamp? So the energy which is converted to other forms, that is the difference. It's going to be the difference in these energies. So that is 7200 minus 7000, which is equal to 200 joules. So the answer is going to be B. An object of mass m is dropped onto the surface of two planets X and Y, which have no atmosphere. The height from which the object is dropped and the change in gravitational potential energy of the object for each planet are given in the table. So for planet X, height is 3, change in potential energy is delta E. So let's start with the planet X. we know that change in potential energy is going to be mg times change in the height. So the change in potential energy for x is going to be equal to mg, which is the mass is m. Let the gravitational field strength at planet x be gx. Then the height is 3. Then for it means similarly for y, the change in potential energy is going to be 4 times delta E. The mass is still m. Gravitational potential field strength at that planet should be gy, then times the height, which is 4. So the acceleration of free fall near the surface of planet X is gx. Let the other one on near planet Y be gy. What is the acceleration of free fall near the surface of planet Y? So I'm going to divide those two equations. So I'm dividing a 4 delta E over delta E equals to 4 m g on planet Y over 3 m g on planet X. So m has cancelled, delta E has cancelled. I'm making gy the subject, so g on planet Y is going to be 3 or 4 times 3 g on planet X, then divide by 4. Okay, so 4 cancels out and I remain with 3 g on planet X, so the answer is C. Water is pumped through a nozzle at the end of a hose. The nozzle has a circular cross-section of diameter 50 millimeters. Diameter is 50 millimeters. A mass of 100 kilograms. A mass of 100 kilograms of water takes time 2 seconds to move through the nozzle. Density of water is 1000 kilograms per meters cubed. What is the speed? What is the speed of the water in the nozzle? So we want the speed of the water in the nozzle. So first of all, we know that volume, because they gave us density, we know that volume is equal to mass times density. Volume is mass times density, but volume is cross-sectional area times another length. So it means volume is cross-sectional area, times another length, which cross-sectional area is pi d squared over 4 for area, because it's a circular cross-section, because they gave us diameter, then times L. So I'll simply say for volume, I'll put there pi d squared L over 4. This should be the same as mass over density. So we can find L. We can make L the subject. I am going to make L the subject. So L is going to be equal to 4m divided by pi d squared times the density. That is L. Remember speed, because we want speed. Speed is distance over, is going to be distance over time, and the time is 2 seconds. The distance is the length. So speed, which I'm calling v, small v, is going to be L over time. So which is going to be L. L is 4 times the mass, which is 100, divided by pi. Diameter is 50, so I'll say times 50 times 10 power negative 2. This is going to be squared. Then times density, which is 1000. Then divide by t, which t is 2 seconds. So I'll simply say times 2 in the denominator because I'm dividing by 2. So I'll check my calculator. In the numerator, I have 400. I'll just solve the denominator first. So in the denominator, I'll start from the other side. 2 times 1000 times pi. Then times open brackets 50 exponent negative 3. And this is squared. So I will get 400 in the numerator divided by 5 pi. So 400 divided by the answer. And I'm getting 25.46. So this is 25.46, approximately 25 meters per second. So our answer is C. A solid wooden cube rests on a horizontal surface. What gives the pressure exerted by the weight on the cube on the horizontal surface? So we know that pressure is equal to force over area. So they are asking what gives the pressure exerted by the weight of the cube on the horizontal surface. Number A is the product of the acceleration of free fall and the density. This is saying A times rho. That is not true. The product of the acceleration of free fall, the density, and the side length of the cube. What gives the pressure exerted by the weight of the cube on the horizontal surface? The product of the acceleration of free fall, that is G, times, oh by the way, this also goes to H rho G. So that is G times the density rho, then times the length of the cube, which is going to be the height. So the answer is going to be B, H rho G. F over area, force over area is H rho G. Which expression could be used to calculate power? We know that power is the rate of transfer of energy. So power is work done over time taken. So this can be force times distance or displacement over time. So the answer is going to be B. A bungee jumper jumps from a platform and is decelerated by an elastic bungee cord as shown. When the jumper makes the jump, his initial gravitational potential energy is converted into his kinetic energy and into elastic potential energy in the cord. At which part of the jump are all the three types of energy not zero, non-zero? On the platform before the jump, kinetic energy is zero there. On the way down, before the cord has started to extend, before it has started to extend, elastic potential energy is zero. So that one is also out. Before it has started to extend, if there is no extension, elastic potential energy is zero. On the way down, as he decelerates, so on the way down, gravitational potential energy is not zero. It has started to change. It is changing. It is not zero. Number two, as he decelerates, it means the cord has started stretching. There is elastic potential energy. Of course, since it is still decelerating, there is a deceleration. It means the velocity is not zero. It means there is kinetic energy. So the answer is going to be C. On the way down, as he decelerates, kinetic energy is decreasing. The cord is stretching. There is elastic potential energy. Of course, he is a certain height above the ground, so there is also elastic potential energy. At the bottom of the jump, when he is stationary, of course, when he is stationary, kinetic energy is zero. Although there is maximum elastic potential energy, yes, elastic potential energy, the gravitational potential energy goes to zero. So the answer is C. An object is displaced horizontally to the right in a uniform vertical gravitational field. Which statement describes the change in gravitational potential energy of the object? The change in gravitational potential energy of the object. So we know that gravitational potential energy is mg times the change in height h. It decreases in direct proportion to the displacement. In other words, the change in the gravitational potential energy decreases in direct proportion to displacement. It does not change with the displacement. It increases in direct proportion to the displacement. It increases in direct proportion to the square of the displacement. So this one is already wrong. An object is displaced horizontally. It is displaced horizontally. That means the change in h does not, the change in h is zero. Because h is in the vertical, change in h is zero. So our answer is going to be automatically B. It does not change with the displacement because the displacement, it is displaced horizontally. So it does not change. Remember, change in h is in the vertical. This is in the vertical. It is not in the horizontal. If it in the vertical, it does not change. Even if it changes in the horizontal, then the gravitational potential energy does not change. It depends on the change in the vertical height. A man of mass 75 kilograms runs up a stair consisting of 30 steps. Each step is 20 centimeters high. The man takes a time 7 seconds to run from the bottom of the stairs to the top. What is the average rate of increase in gravitational potential energy? So that is power. Rate of increase in gravitational potential energy. Because of the part of rate, it is energy over time. So potential energy, let's first find the distance. Distance is going to be equal to there are 30 steps, so it will be 30 times the height of each step, which is 20. So this becomes 600 centimeters. And 600 centimeters, I think, is 6 meters. Then we want the rate. What is the average rate of increase in gravitational potential energy? So that is actually power, which will be mgh divided by t. So mass is 75 kilograms, g is 9.81 times h, which is 6, divided by time, which is 7.0. So 75 times 9.81 times 6 divided by 7, which gives us 630. So this is 630 watts. So the answer is C. A rock of mass 2 meters, a rock of mass 2m, traveling in deep space at velocity v, explodes into two parts of equal mass, one of which is then stationary. It explodes into two parts of equal mass, one of which is then stationary. What is the kinetic energy of the moving part after the explosion? So by conservation of momentum, we know that momentum is equal to mass times velocity. So the rock was moving, so its initial momentum was 2m, then times the velocity v. That's initial momentum, and it explodes into two parts of equal mass. So if it is in two parts of equal mass, each mass must be m. Since the total mass of the rock was 2m, so each mass is going to be m. One is stationary, so its velocity is 0, plus the other one is now moving, so its mass is m. Let its velocity be v2. Let its velocity be v2. So the m has cancelled, so we have that 2m times v is equal to m times v2, which means that v2 is going to be twice m. M has cancelled, so it is twice v. So v2 is going to be twice v. Now let's look at conservation. Let's look at kinetic energy. So the kinetic energy is going to be a half m times v squared. So this will be a half m. Where there is v, I'm going to put there v2, which is twice. So this will be v2 squared. This is twice v squared. So this is going to be a half m times 4v squared. So 4 reduces and we get twice mv squared. So our answer is going to be D. An alpha particle has 2.2 times 10 power negative 13 joules of kinetic energy. What is the speed of the alpha particle? So it has that energy. So we know that kinetic energy is equal to a half m v squared. At this point, we should be knowing the mass of an alpha particle. The mass of an alpha particle is 4u, which is 4 times 1.66 times 10 power negative 19. So negative 27 kilograms. This is 1u. It is given in the list of constants. So we shall say that 2.2 times 10 power negative 13 is equal to a half times the mass, which is 4, times 1.66 times 10 power negative 27, that is in kilograms, then times v squared. So I'll just check with my calculator. 2 times 2.2 exponent negative 13 divided by 4 times 1.66 exponent negative 27. Then I find the square root. So I'm getting 8.1 times 10 power 1, 2, 3, 4, 5, 6 times 10 power 6. So V is 8.1 times 10 power 6 meters per second. So our answer is going to be C. The total energy input in a process is partly transferred to useful energy output U and partly transferred to energy that is wasted W. What is the efficiency of the process? Remember, efficiency is equal to the useful power output or energy output divided by energy input. Then times 100. So the useful energy output is given as U. The energy input is given as E in. Then we multiply this by 100, making our answer to be A. An escalator is 60 meters long and lifts passengers through a vertical height of 30 meters, as shown. To drive the escalator against the forces of friction when there are no passengers requires a power of 2 kilowatts. The escalator is used by passengers of average mass 60 kilograms, and the power to overcome friction remains constant. The power to overcome friction remains constant. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meters per second? Okay, so first of all, we know that power is equal to energy divided by T. Of course, the time T is going to be the same. The time T is going to be the same. So first of all, we shall find, they have told us the power. When there are no passengers, it requires 2.0 kilowatts if it is the escalator alone. Now let's find the power when the power needed to carry the passengers. So the power to carry the passengers, power is going to be equal to energy or work done over time taken. So this will be work done over time taken. So the work done is going to be the force times the distance divided by the time. So the time, let's first of all find the time it takes, because the time is going to be the same. The time is, I'm going to use how much power is required to drive the escalator when it is carrying 20 passengers, and is traveling at the speed of 0.75 meters per second. So the speed is 0.75 meters per second, but notice the distance it is going to move through is 60. So time is distance over speed. Time is distance over speed. So this is going to be 60 divided by speed, which is 0.75. So this is the time in seconds. So I'm now substituting. The force is going to be the weight, which is m times g, then times the distance traveled through, then divide by the time. So I'm now substituting. The force m is 60, but there are 20 passengers, so 60 times 9.81. Then I multiply this by 20 to get the total weight. The distance it is going to travel through is 60 meters. Then the time is 60 over 0.75. That is the time it is going to take. So let's find that power. 60 times 9.81 times 20 times again 60 divide by 60 divided by 0.75. 60 times 9 point, did I forget something here? 60 times 9.81. Oh, sorry. This is not going to be 60. This is mgh. let this be work done be equal to the work done to move the passengers in the vertical height. Let's consider the height h. Of course, the time in the time while moving will be the same whether we consider 60 or the vertical height. The time is going to be the same. So this is going to be mg times the height h. So this is mg h over t, gain in gravitational potential energy. So that is 60 times 9.81 times 20. Then this will be 30 times 30. So this becomes 60 times 9.81 then times 20. That is the total weight. Then times the vertical height, which because we are overcoming the weight, so that's why I'm considering vertical height rather than distance of 60. We are overcoming the weight of the people. So times 30. Then I divide this by 60 divided by 0.75, which is the time. So this is giving me 4.4 kilowatts. So this is 4.4 kilowatts. But remember, the escalator alone required a power which was 2.0 kilowatts. So it means the total power is going to be 2.0 plus 4.4, which gives us 6.4 kilowatts. So this is going to be the total power. Okay. So this was force. This was actually mg times h, force times the vertical height. So total power is going to be 6.4, which makes the answer to be B. A rock of mass 40 kilograms is released from rest from a height of 20 meters above the surface of a planet. The rock has a kinetic energy of 32 kilojoules when it hits the surface of the planet. The planet does not have an atmosphere. What is the weight of the rock on the surface of the planet? So here we just use conservation of energy. The loss in gravitational potential energy should be equal to the gain in kinetic energy. So loss in gravitational potential energy should be equal to the gain in kinetic energy. So the loss in gravitational potential energy is mgh. The gain in kinetic energy will be a half mv squared because it starts from rest. Initial kinetic energy was 0. So m has cancelled. And we want to find the weight. Or let me leave there m. What is the weight of the rock on the surface of the planet? So let me leave m there so that I just find mg. So mg is the weight. I'm leaving the m there. I'm not crossing out m. I said loss in gravitational potential energy is equal to the gain in kinetic energy. So I'm saying mgh is equal to a half mv squared. So I want the weight, which is mg, so it will be a half, which is 0.5, times the mass, which is 40, times the speed, Oh, we have the kinetic energy. Why am I wasting time? So the kinetic energy is 32 kilojoules, so I'll say 32 kilojoules. Then I'll divide by h. This part here is 32 kilojoules, so I'll just divide by h, which h is 20. So we have kilojoules divided by 20 meters. So it means our answer is going to be kilojoules per meter, which is kilonewtons. So 32 divided by 20, that is 1.6. So this is 1.6 kilojoules per meter, which is the same as kilonewtons. Or you could remove the kilo, then get joules per meter. Then that is the same as, that will be 1,600, which will be 1.6 kilonewtons. So the answer is going to be C. The box slides down a rough ramp. The change in gravitational potential energy of the box is 16 joules as it moves down. It moves between positions X and Y. And the box has 24 joules of kinetic energy at X and 35 joules of kinetic energy at Y. So there is a change in kinetic energy. As the kinetic energy increases, the gravitational potential energy is actually decreasing. So how much work is done against the frictional force? So the loss in gravitational potential energy, should we expect it to become the kinetic energy and also to become or to do work against the friction? I'll call the work done against friction WF. Therefore, the loss in gravitational potential energy is going to be equal to the gain in kinetic energy, or the change in kinetic energy, plus the work done against friction, or the work done against resistance. So the loss in gravitational potential energy, the change in gravitational potential energy is 16 joules. So we shall say 16 is equal to um, the change in kinetic energy is, or the gain in kinetic energy is 35 minus 24. So that is 35 minus 24. Then plus the work done against friction. So it means 16 is equal to, I think this is 11, plus the work done against friction. So it means the work done against friction is going to be 16 minus 11, which gives us 5 joules. So the answer is going to be A. Total energy supplied to an electric motor is E. Energy Q is wasted and the remaining energy does useful work. What is the efficiency of the motor? So remember, efficiency is equal to the useful energy output over the energy input. The useful energy output over the energy input. So the efficiency is going to be equal to the energy output is going to be, because the energy supplied is E, that is the energy input, and energy wasted is Q. So the energy output is going to be E minus Q divided by E. So when we divide by E, each of these by E, so it becomes E divided by E, that is 1, then minus Q divided by E, that is Q over E. In the denominator, E divided by E is 1. So the answer remains 1 minus Q over E. So 1 minus Q over E means that the answer is going to be C. Which product of two quantities is equal to power? We know that power is work done over time taken, force times distance over t, or force times velocity. So our answer is automatically B. Researchers have developed a new type of filament lamp with an efficiency of 40%. The old type filament lamps have an efficiency of 5%. The two types of lamp produce the same useful output power. So power output is the same. What is the ratio of input power to the new type of lamp over input power to the old type of lamp? So that is very easy. Let me consider the new type. The new type efficiency is 40%, so I'll say 0.40 is equal to the power output over the power input. Then for the old type, the efficiency is 0.5 is equal to the power output. So I will call this one P1 for the new type. I'll call it P1. For the old type, I'll call it P2. Okay. So the question is saying what is the ratio of input to the new power of lamp over input to the old type of lamp. So let's just because P out is the same, I'll just cross multiply and I get 0.4 times P1 is equal to P out. And also for the other side, I have that 0.05 times P2 is also equal to P out. So I just equate the two equations. So I have that 0.4 P1 is the same as 0.05 P2. So I want P1 over P2 because P1 is input in the new. So I have P1 divided by P2 will be equal to 0.05 divided by 0.4. So 0.05 divided by 0.4, that gives us 0.125. So the ratio here is 0.125, which is approximately 0.13. So our answer is going to be A. A student attempts to derive the formula for kinetic energy EK. She begins by considering an object of mass m, which is initial at rest. A constant force F applied to the object causes it to accelerate to a final velocity v in a displacement s. The kinetic energy gained by the object is equal to the work done on the object by the force. The kinetic energy is equal to the work done by the force. Remember, the work done is force times distance. And of course, the force is ma. So this is also equal to ma times s. So we need this one. We need the force is equal to ma. And we need to replace as. As is going to be v squared minus u squared. As is going to be v squared minus u squared divided by 2. But remember, u squared is s. So we also need this one. So it means we don't need this one. So this is out. What is meant by the efficiency of a system? What is meant by the efficiency of the system? Of course, efficiency is the ratio of the useful energy output to the energy input, or the total energy input. Useful output. So this one is showing difference between. It is not difference. It is a ratio. Useful energy output from the system to the total energy input in the system. So the answer is C. A car of weight 15,000 is traveling along a horizontal road. At one instant, the thrust force acting on the car from the engine is 12,000. The resistive force acting on the car is 3,000. The velocity of the car at this instant is 24 meters per second. What is the power output from the engine? Of course, the power output from the engine, we shall only consider the thrust force, because the thrust force is the one trying to overcome resistance and driving the car forward. So it means the power is simply going to be equal to force times velocity. We shall not need to consider the weight. The power is force times velocity. So this is the force is going to be the thrust force, which is 12,000, not the weight. It is the force, the driving force. So it is 12,000 times the velocity, which is 24. So the power is going to be 12,000 times 24. It is not the weight. We don't use the weight, we don't use friction, but we use the total force needed to move the car forward. So this is 288,000, which gives us approximately 290 kilowatts. So the answer is going to be C. The diagram shows the variation of a quantity y with a quantity x for objects in a uniform gravitational field. A uniform gravitational field. What could x and y represent? X, mass for different objects moving at different speeds, and y, kinetic energy. That means it is a graph of kinetic energy against mass. Kinetic energy against mass, when you look at kinetic energy is equal to a half m v squared. This would be directly proportional. So it would not be a curve of increasing gradient. So this is out. Speed for an object of constant mass and kinetic energy. So you see that kinetic energy is directly proportional to v squared. That means kinetic energy increases more rapidly as v increases. So this would be correct. V on the x-axis, because v is squared, it means kinetic energy is going to be, the gradient must be increasing. So this is kinetic energy against v. Because to find kinetic energy, we must be squaring v. So the answer is going to be B. Because of the square on v, the gradient must be increasing. An electric motor produces 120 watts of useful mechanical output power. The efficiency of the motor is 60%. Which row is correct? Which row is correct? Which row is correct? Okay. So we know that efficiency is equal to power output, which is given as 120, over power input, which I'll just say power in. So we just check which of these ones so which row is correct, okay? An electric motor produces 120 watts of useful mechanical output. So this is going to be equal to the efficiency, which is 60%, that is 0.6. So power input is going to be 120 divided by 0.6. So 120 divided by 0.6 is 200. So power input is 200. So A and B are out. So have C and D. Then waste heat power. So power wasted, I'll call it power wasted, is going to be the difference. So this is going to be 200 minus 120, which gives us 80. So the answer is D. A fixed amount of gas undergoes a series of changes to its pressure and volume. In two of the changes, no work is done by or on the gas. In one change, work is done by the gas on its surroundings. In another change, work is done on the gas by its environment. During the change when work is done on the gas, of course on the gas the volume must be decreasing. This is the part here. This is the part where the volume is decreasing, work is done on the gas by the surrounding. How much work is done by the gas? So work done is equal to pressure times change in volume. So the pressure is 1.0 times 10 power 5 pascals, and the change in volume is from 5 to 3. From 5 to 3. So the change in to 2. The change in volume is going to be 3 times 10 power negative 4. Note those values very carefully. So we check with our calculator. 1 exponent 5 times 3 exponent negative 4, which gives us 30. So this is 30 joules. So the answer is C. An object traveling with a speed of 10 meters per second has kinetic energy 1500 joules. The speed of the object is increased to 40 meters per second. What is the new kinetic energy of the object? So that is easy. Kinetic energy is a half mv squared. And for the first object, it is a half mv squared is equal to 1500. That's when v is 10. So I'll just say a half m times 10 squared gives us 1500. Then for the second one, a half m and the v is 40 squared. It should give us another value of kinetic energy. So when I divide the two equations, you notice that a half m has cancelled out. I'm dividing ek by 1500. So this will be 40 squared divided by 10 squared. So what is ek? So 40 squared divided by 10 squared, then times 1500. So that is 24,000. So our answer is C. The engine of a car exerts a force 600 newtons in moving the car 1 kilometer in 150 seconds. What is the average useful output power of the engine? Output power. So since we have the force and we have distance and time, we shall find the speed. So power is equal to force times velocity. So power will be the force, which is 600. The velocity will be the distance divided by the time. So this will be 1000 divided by 150. V is going to be distance over time. So this is going to give us 600 times 1000 divided by 150 seconds. So this gives us 4000 watts, which is 4 kilowatts. A power station using coal as fuel has an average power output of 300 megawatts. Coal is supplied by 20 trains each day. The efficiency of the station in converting the thermal energy released from the coal to electrical energy is 26%. So that is the efficiency. A mass of 1 kilogram of coal will release 33 megajoules of thermal energy when burnt. Which mass of coal does each train? So we shall divide the mass by 20 if we get the total mass. First of all, we know that energy is equal to power times time. Let's see the energy input. So the energy input will be the power, which is 3000 megawatts. That is 3000 times 10 power 6. That is the power. Then times the time. The time is each day. Each day, so one day is 24 hours times 24 hours times 3600 to change it to seconds. So that is the energy input. But remember, this is going to be divided by the efficiency, which is 0.26. The efficiency of the station in converting the thermal energy released from the coal to electrical energy is 26%. So only 26% of the energy we had, energy input is the one which is converted. So this is going to be divided by 0.26. Or you can say 0.26 is equal to energy output divided by the energy input. So you end up finding that the energy we need, or the energy which is converted, let me just say the energy converted. Energy converted is going to be 0.2, that one, 3000 times 10 power 6 times 24 times 3600 over 0.26. That is the energy converted. Then let's find the mass. If it is hard for you to notice this, just know that power input is going to be 3000 times 10 power 6 divided by 0.26, because power input times 0.26 is going to be equal to the power output, because efficiency is equal to power output divided by power input, but the efficiency is 26. So 26% times power input gives us the power output. So that's why I'm saying the energy converted is the power output, which is 3000 times 10 power 6 times the time, which is 1 day, then divide by 0.26. But remember, for every 33 megajoules, for every 1 kilogram, there are 33, it releases 33 megajoules. So let's see the mass here. So mass is now going to be this energy divided by the energy for 1 kilogram. So that is going to be 3 times 10 power, this becomes power 9, times 24 times 3600 divide by 0.26. Then we divide by the energy for 1 kilogram. So divide by 33 times 10 power 6. Now that is total mass, but we want the mass for each train. So again, I will divide this by 20. So this one cancelled. Oh, okay, let me leave it. I will divide by 20 to get the mass for 1 train. So let's just check 3 exponent 9 times 24 times 3600 divide by 0. Let me put a bracket, 0.26 times 33 exponent 6, then divide by 20. So each train is going to bring 1.5 times 10 power 6 times 10 power 6. So the mass of each is 1.5 times 10 power 6 kilograms. So the answer is going to be C. A wooden cylinder floats partially submerged in a bath of water. A force F is applied to the cylinder until it is fully submerged. Which statement is not correct? Some of the water gains gravitational potential energy. That is correct. Water rises as the cylinder sinks, water is rising. The cylinder loses gravitational potential energy. That is also correct because its height decreases, it goes down. Work is done by the force on the cylinder. Yes, work is done because there is a change in distance. The cylinder moves a distance. Work is done by the upthrust on the cylinder. There is no work done by the upthrust on the cylinder because the upthrust is not changing the upthrust force is not causing the cylinder to move in any way. Remember, the upthrust will be equal to the cross-sectional area times change in pressure, and the change in pressure depends on the change in the height. Now, if the cylinder is fully submerged, then there is no work done by the upthrust because the upthrust is not going to cause any distance, any movement of the cylinder. So there is no work done by the upthrust. The motor of a crane lifts a load of mass 600 kilograms. The load rises vertically at a constant speed of 12 meters per minute. What is the useful power output? Of course, we know that power is going to be force times velocity. This time the force will be the weight. The weight times the velocity. So the weight is 600 times g, which is 9.81 mg. The velocity will be, they gave us 12 meters per minute. I will just change it per second. So it will be 12 meters per second will be divided by 60 to change it from per minute to per second. So this is 600 times 9.81 times 12 divided by 60. So that is 1177.2. So that is approximately 1.2 kilowatts. So the answer is going to be B. The trains supply coal to a power station. The table shows quantities describing the operation of the power station. Which expression gives the efficiency of the power station? So remember, efficiency is equal to power output over the power input, which is going to be the same as the energy output over the energy input. So power station average output is P, that is average output. The number of seconds in one day is S, so it means the energy output is P times S. So this is going to be P times S over number of trains per day is N, mass mass on a train, mass of coal on a train is M, and the energy from 1 kilogram of coal is E. So total energy there is going to be E times the number of trains N times the mass of coal from each train, which is going to be M. Because if 1 kilogram gives energy E, that means M kilograms should give a mass energy which is M times E. But then there are N trains per day, so it is total energy will be E times N times M. So this is going to be E times N times M. So our answer is going to be A. PS is the energy output, NME is the energy input. A piston in a gas supply pump has an area of 500 centimeters cubed and it moves a distance of 30 centimeters, so the volume can be 500 times 30. The pump moves the gas against a fixed pressure of 4,000. How much work is done by the piston? So work done is pressure times change in volume. So this is 4,000. Change in volume will be 500 times 30, then times 10 power negative 6 to change it from centimeters cubed to meters cubed. So this will be 4,000 times 500 times 30 exponent negative 6. So that gives us 60. So the answer here is 60 joules. So this is A. A steel ball is falling at a constant speed in oil. Which graph shows the variation with the time of the gravitational potential energy EP and the kinetic energy EK of the ball? So first of all, it is falling. That means potential energy must be decreasing. Potential energy must be decreasing. and in both cases we see that potential energy is decreasing. But a steel ball is falling at a constant speed. It is falling at a constant speed. That means the kinetic energy is not changing. Kinetic energy is remaining constant, so we eliminate C and D because C is showing an increase in kinetic energy and D is showing an increase in kinetic energy. Which graph shows the variation with the time of the gravitational potential energy EP and the kinetic energy EK of the ball? Now, if the kinetic energy is not changing and it is falling in oil, the kinetic energy is remaining constant and it is falling in oil, then we can say the change in potential energy is going to be therefore uniform because the change in potential energy is mgh. The mass is constant, g is constant. The height decreases uniformly, so it means the answer is going to be B rather than A. A is showing the height does not decrease uniformly, so the answer is going to be B. The maximum useful output power of a car traveling on a horizontal road is P. The total resistive force acting on the car is kV squared, where V is the speed of the car and K is a constant. Which equation is correct when the car is traveling at maximum speed? So we know that force is equal, they say the force is equal to kV squared. And we know that power is equal to force times the speed. So it means the power is going to be where there is force, I'm putting kV squared then times V, which becomes kV cubed. So which equation is correct when the car is traveling at maximum speed? So they have made V the subject here. So we can check, we notice that V cubed can be equal to power divided by K. So the answer is going to be A. Initially, 4 identical uniform blocks, each of mass m and thickness h, are spread on a table. The acceleration of free fall is g. How much work is done on the blocks in stacking them on top of one another? Remember, work done is going to be mgh when they are stacked together. For the first block, h is the change in height is 0, so this one is going to be 0. For the second block, it is moved through a height h, so this one is going to be mgh. For the third block, it is going to be moved through a height h plus h, which becomes twice mgh. For the fourth block, it is moved through this height, and this height here. So this becomes 3 mgh. It is moved through a height of 3h. So how much work is done on the blocks in stacking them on top of one another? So total work done is going to be 3 mgh plus 2 mgh plus mgh plus 0, which gives us 6 mgh. So our answer here is automatically B, 6 mgh. Which statement about energy is not correct? Energy. Number 1, energy is never lost, but it may be transferred between different forms. That is correct. In an elastic collision, total energy is constant. Of course, total energy remains constant, although kinetic energy is not conserved. The efficiency of a system is the ratio of the useful energy output to the total energy input. That is a correct statement. When a machine does work, friction reduces total energy. When a machine does work, friction reduces total energy. This statement is not correct. When a machine does work, friction wastes energy. So in other words, energy is converted into other useful forms, but total energy is not reduced. The total energy is constant. A pulley of radius 0.4 meters supports weights of 20 newtons and 15 newtons by means of a thin string as shown in the figure here. The weights are moved by slowly rotating the pulley clockwise through an angle of 60 degrees. What is the increase? What is the increase in the total gravitational potential energy of the weights? Increase in the gravitational potential energy of the weights. Okay, I'll use simple mathematics. The circumference of the pulley is going to be equal to 2 pi times r, then times, but the distance moved through by the pulley in an angle of 60 degrees will be a fraction of the circumference. So it will be 2 pi times the radius, which is 0.4, times the distance, the angle, which is 60, as a fraction of 360 degrees. So this is the distance moved through by the pulley. So this is going to be, okay, let me just leave it at that point first. Then we want the increase. So if the pulley moves through this distance, it means the height through which this mass moves is also the same. So it means the potential energy here is going to be equal to the potential energy, the gain in potential energy of 20 newtons is going to be equal to, so let's say the E of 20 is going to be the M. Remember, potential energy is mgh. So this is going to be the mass, which is 20, mg, which is 20 newtons. The distance moved is this one here, which is 2 pi times 0.4 times 60 over 360. So this one gains potential energy. So it is 20 times 2 pi times 0.4 times 60 divided by 360. So this one, the energy gained here, the energy gained by this one is 6.378. 8.378. 8.378 joules. Then the energy lost by the 15 newtons is going to be 15, because they move through the same distance. So it will be 15 times 2 pi times 0.4 times 60 over 360. The same distance. They moved through the same distance. So 20 is the weight, 15 is the weight. It is the mg part. So this gives us 15 times 2 pi times 0.4 times 60 divided by 360, which gives us 2 pi, and that is 6.283. 6.283 joules. So we want the increase in gravitational potential energy. Remember, 20 gains potential energy and 15 loses potential energy. So the increase is the difference. So the difference in potential energy is going to be 8.378 minus 6.283. So just subtract 8.37578 minus 6.283. So which gives us 2.095, which is approximately 2.1. Approximately 2.1 joules. So the answer is going to be C. A car of mass 1,500 kilograms accelerates from an initial speed of 15 meters per second. This acceleration causes the car to gain 3 times 10 power 5 joules of kinetic energy. What is the change in the speed of the car? What is the change in the speed of the car? Okay, so the change in kinetic energy is equal to a half m times v squared minus u squared. So this means 3 times 10 power 5 is going to be equal to a half times 1,500 into v squared. What is the change in the speed of the car? Okay, so I'll just say, okay, I will have to find v squared minus 15 squared. We want the change in the speed, not the change in the speed squared. so minus v squared. So I'll find v squared first. So I'll say 3 exponent 5 times 2 divide by 1500. Then I add plus 15 squared. I'm just making v squared the subject. So it means v squared is equal to 625. V squared is equal to 625. We find the square root, which is 25. So v is 25. So we want change in speed, change in v, not change in v squared. So change in v is going to be 25 minus 15, which is equal to 10 meters per second. So the answer would be B. A car of mass 1,500 kilograms travels at a constant velocity of 30 meters per second down a slope. The slope is at an angle of 60 degrees to the horizontal. The magnitude of the total resistive force acting on the car is 2,000 newtons. What is the power output of the car's engine? So the speed is constant. That means the acceleration is 0. So the resultant force is 0. So, and the force due to the resistive force is 2000. So what is the power output of the car's engine? Okay, so the force, the driving force down the slope, plus the force, the component or the force which is down the slope, the driving force of the car, plus the force down slope should be equal to the total resistive force. Why? Because there is no resultant acceleration, there should be no resultant force. Since there is a force, there is a driving force by the car, which I'm calling Fd. There's also a component of its weight which is down the slope. There's a component of its weight which is down the slope, which I'm calling F down the slope. So that is the component of the weight down the slope. And that component of the weight down the slope is going to be the mass, which is 1,500 times g, which is 9.81. When we resolve down the slope, that would be sine. So that would be sine of 6.0. That is the component of the weight down the slope. So I will simply say, and also remember, the power is equal to force times distance. So total power, so this is going to be the driving force. So the driving force is going to be the power divided by the distance. So where there is Fd, I'll put their power divided by the distance along the plane. That distance is, what is the distance? Sorry, let me use power is force times velocity, not times distance. Power is the driving force times velocity, so Fd is going to be power over the velocity. So this is going to be power over velocity, which is 30, plus the force down the slope, which is 1,500 times 9.81 sine of 6.0 should be equal to total resistive force is, I think, 2,000. Total resistive force is 2,000. So let's just solve this. I'll just say 2,000 minus open brackets 1,500 times 9.81, then times sine of 6. So that is 461. So that I'll just multiply times 30 because I'm making P the subject. So I'm getting 13,855. So P is 13,855. 13,856 when you round off. So the values here are given in kilowatts. So this is 1, 2, 3. So it is 13.9 or approximately 14 kilowatts. Approximately 14 kilowatts. So the answer is going to be A. A ball is thrown vertically upwards into the air, it raises to the top. It raises to the top of its path before beginning to fall vertically downwards. Okay, it raises to the top. Assume that the gravitational potential energy of the ball is zero at its starting position. Which statement about the ball is not correct? As it raises, its kinetic energy is transferred to gravitational potential energy. That is true. At the midpoint of its path, its gravitational potential energy is equal to its initial kinetic energy. Remember, the ball is at the gravitational potential energy of the ball is zero at its starting point. That means it is increasing. And as it is increasing, the kinetic energy must be decreasing. So which statement about the ball is not correct? At the midpoint of its path, its gravitational potential energy is equal to its initial kinetic energy. It can't be equal to initial kinetic energy because the kinetic energy is decreasing as it moves upwards. Velocity reduces, so this one is not correct. At the top of its path, kinetic energy is zero. That is true because velocity becomes zero at the highest point. At the top of its path, the total energy is less than its initial total energy. At the top of its path, its total energy is less than its initial total energy. At the top of its path, its total energy is less than its initial total energy. I think this is also making sense, but this one does not make sense. An object slides with constant velocity across a horizontal sheet of ice. Friction is negligible. A constant horizontal force of 2.1 Newton is then applied to the object as shown. A short time after applying the force, the object reaches point X at a displacement of 4 meters from its position when the force was first applied. What is the work done by the force on the object as it travels to point X? So we know that work done is equal to force times displacement in the direction of the force. The force is going to still be 2.1, but this time we are going to resolve the force. The force is in the horizontal. So I'm going to resolve it to in the direction of the distance. So it will be 2.1. When I resolve from the horizontal to the direction of x, it will be cos. So that will be cos of 30, then times 4.0. Alternatively, I can resolve 4.0 to the horizontal. Taking 4.0 to the horizontal, it becomes 4.0 cos of 30. Then I multiply this by the force, which is 2.1. It is the same thing. So we can check this. 2.1 cos of 30 times 4.0. That gives us 7.3, automatically 7.3 joules. So the answer here is C. Lastly, this is the last page for this episode. The energy conversion inside the power station burning fossil fuel can be simplified as shown. Chemical energy, thermal energy, electrical energy. Which expression gives the efficiency of the power station? Remember, efficiency is going to be the useful energy output over the energy input. So the useful energy output is the electrical energy. The energy input is actually W. So the answer is automatically A. The thermal energy is wasted, so it's not going to be useful here. So the answer is A. Car X is traveling at half the speed of car Y. Car X has twice the mass of car Y. Which statement is correct? This is simple mathematics. Car X has half, okay, let's say car X is traveling at a speed of car Y. Let's begin with the car Y. Its kinetic energy is going to be a half m times the speed v squared for car Y. Then for car X, its kinetic energy is going to be a half. Its mass is twice, so it is twice m. Its speed is half, so it is times a half of v squared. So kinetic energy of x, let me call it Ex. This was E for y. Ex is going to be this one cancels. A half v squared is a quarter, so this is 1/4 m v squared. Compare this fraction, this value here with this value here. You notice that if I multiply this one by 2, I get Ey. So it means E for y is equal to twice E for x. So car x has half the kinetic energy of car y. Car x has half the kinetic energy of car y. That is very true. E of x is a half of E of y. So this is very correct. I don't need to check the rest. The total weight of a motorbike and rider is 1,800 newtons. The motorbike travels in a straight line at a constant speed up a hill at an angle of 30 degrees to the horizontal. The useful output power of the motorbike is 36,000 watts. The total resistive force due to air resistance and friction on the motorbike and the rider is 2,400 newtons. What is the speed of the motorbike? Okay. I want you to note, let's first put an arrow here for the driving force upwards. I want you to note that there is a component of weight which is down the slope, and that component is always mg sine. So mg, the mg is 1,800, so we shall say this component is 1,800 sine of 30, which is I think 900. Okay, so what is the speed of the motorbike? So we can first of all find the driving force. The driving force upwards, when I subtract, because it's upwards, I'll have to subtract the component of the weight down the slope minus the force down the slope should be equal to the force due to the resistance, because the speed is constant, so the resultant force is 0. So Fd, of course, driving force, power is going to be the force driving times the speed. So where there is Fd, I'm going to put their power over V. So this is power over V minus the force down the slope is 1,800 sine of 30 should be equal to the resistive force, which is 24,000 or 2,400. So the power is 36,000 divided by V minus this one is 900. 1,800 sine 30 is 900 should be equal to 2,400. So let's find V. I'll just say 2,400 plus 900. Then I'm going to make a V the subject, so it means I'm going to divide 3. Okay, this is 3,600 is equal to 3,300 times V. So it means I'm going to say 3,600 divided by the answer, which is 1.09, which is 1.1 recurring. Is that true? Oh, this is 36,000. 36,000. Okay, let me check it again. So 36,000 divided by 3,300. That is 10.90 recurring. So that is 10.9 or 11. So V is going to be equal to 11 meters per second. So the answer is B. A mechanical device does useful work at a rate x and wastes energy at a rate y. Which expression gives the efficiency of the device? So the efficiency is useful work output over work input. So it wastes energy at a rate y. It wastes energy at a rate y. So power wasted is y. Power output is x. So efficiency is equal to power output over power input. So power output is x, but power input is going to be y plus x, so that is x plus y. So it means our answer here is going to be C, which is x plus y. This is the useful output. This is the total input. That is output plus wasted. That is total input. So the answer is going to be C there. Car P has kinetic energy of 240 kilojoules. Car Q has the mass and has half the mass and twice the speed of car P. What is the kinetic energy of car Q? So we know that kinetic energy is a half m v squared. So for P, 240 is equal to a half times the mass times v squared. Then for Q, the kinetic energy is Ek equals to a half. Let's check the mass is a half, so it is a half of m. The speed is twice, so this is 2v, but this is squared. So some of these things cancel when I divide. So I have Ek divided by 240. A half has cancelled when I divide. M cancels when I divide. So I remain with a half here, which is 0.5 times 4v squared divided by v squared. So v squared cancels out also. So it means Ek is going to be equal to 0.5 times 4 times 240, which is 2 times 240, which is equal to 480. So the answer is automatically C. Okay, let's part 1 stop there. See you in part 2. Bye bye.